Okay, let's do this. All right, yeah, we are live. Hell yeah. I have no idea how low the audio is. I know what I can do. It's audio properties, bump it up. Alright, yeah, that's probably a little better. Because I'm not super close to my mic, but as I get closer, it probably gets better, yeah. But I don't want to have to be breathing into my mic to talk. Alright, let's see here. How do I generate a link? Copy video URL. Let's share it. Get some people on the stream, and we'll start work. Share it there, share it in my Discord. I'm not going to ping people for that. And then Redcraft, post that in there, and then in the top red, Multiplier. Is there anywhere else? No, that's probably about it. I don't want to spam it anyways. Cool. And now we'll switch scenes. Alright, what's up, guys? So, hopefully, I was having some issues before with whatever it's called, OBS. It was cutting out the stream on me before, but I think it's because I had my bitrate set too high. I'm hoping now with lowering it, everything works out fine, and we're good to go. Yeah, so for those of you who don't know, this is what Logic World looks like. It's basically just a giant world, a grid world, where you're able to build circuits. For instance, here is a line drawer that I made. And hopefully, I believe, this mod should be on the server now. I'll know by if I place a component next to it if it disappears. So that mod's not on the server yet. So I gotta get that added in. But that's not going to prevent us from working on the actual hardware for the Mandelbrot still, which we're going to need some Vedic multipliers. And to build the Vedic multipliers, I'm going to have to build a synced adder, which I have right here. So I'm going to grab this adder, and I'm going to come over here to, well, that's where I'm building the CPU, and that's the line drawer, so I guess over here will be present Mandelbrot. Anyway, so what we got to do is I will pull up a picture here. What we're going to do is we're going to build something called a Vedic square, and the way Mandelbrot works is it's a bunch of squaring, multiplication and squaring. And so to actually get this done, what is this yelling at me about? Warning, please check the video resolution. The current resolution is 10. Which is not optimal. Well, whatever, as long as it works. As long as it works. We got any chat? No. Yeah, so anyway, we got to build a Vedic multiplier. And to do this, well, I really just need the squares, and the multiplier doesn't have to be Vedic based. So I really just want to build the Vedic square, and I was going to build this as a 32-bit machine, but I think I'm going to do 16 bits now. I think that's a smarter way to go. And so we're gonna use this, and if we need a 4x4 square, there's only one input to a 4x4 square. It's just a 4-bit number, and then it outputs the square of that number. So you're basically, you know, it's showing 4x4 as if you're like multiplying two 4-bit numbers, but you only really need one 4-bit input, right? Whereas the multiplier needs 2 different 4-bit inputs. Okay, so what I got to do is build some squaring circuits, and that's pretty easy because we can use lookup tables for the 4-bit one. And so we can start with that, and then we're going to need a 4x4 multiplier, which can also be kind of cheated in. So let's do that. So I need to grab a decoder. Huh, did Commander must have screwed, got rid of mods on the server, because there was RAM component hooked up there. Anyway, I need a decoder. We'll grab a full fat one here. Okay, and so with the decoder, there's going to be no output from 0, so we don't need to decode 0. So you can really grab it from here. GR. So we have 1, 2, 3, 4, yada yada yada, up to 15. Cool. So now what we need to do is encode a value on the output from this. So I think the easiest way to do that would be probably doing something like this. And then if you, yeah, that would work perfect actually. All right, so we'll just boom, boom. Or I can just copy, Control G. That's actually a little faster, I think. So I'm going to use the property of these inverters as diodes, as well as also their inversion property. Who is that? I know what you're talking about, but who? Like, how do you know that reference? I don't recognize your YouTube name. Alright, so the input there is 4 bits, so the output has to be 8 bits, and I think maybe the easiest way to do this would be like this. Two, three, 4, 5, 6, 7, 8. Oh wait, I'm dumb. I could just put those here. 1, 2, 3. Whoops. Resize this board. Don't need that coming all the way across like this. I should just grab that, delete that, delete that, and place it here. Boom. Oh, great! That's hysterical. All right, so now we gotta do some squaring here. So wait, hopefully this will reach. God damn it. All right, so 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 36, which is 32 plus 4. 7 times 7 is 49, right? Oh god. I just want to double check this. 0, 1, 1, 0. Alright, so it's 3, 1 in hex. Then what is this? 8. 8 squared is 64. That's really easy. We go there. 9 squared is 81. 5, 1 in hex. Oh, that'll reach. Okay. 5, 1. 100. 6, 4 in hex. What is this? 11 times 11. Shit, what the fuck is that one? Do it out. 121, 7, 9. What the fuck? Alright, 12 squared is 144, I believe. Yep, and that is 9, 0 in hex. To be honest, I like digital the most right now, because of the flexibility. Like, I already did this in digital, and it was really quick to do in digital. Well, by really quick, it took me like a few weeks rather than like months of planning and building hardware out. I want to get to the point where I can just throw it on my FPGA, which I was about to do with my previous Mandelbrot renderer that I did in digital. The issue is my FPGA physically doesn't have enough RAM built in to support the size screen I want to be able to display to. I'm limited to about 32 by 32 with 16-bit color, like 444 RGB, and that fucking sucks. So I need to buy an FPGA that has DDR3 RAM, and then I need to use like a Xilinx IP block to actually communicate with that, and it becomes so much more of a project at that point. You know, you go from just, you're at the cusp of actually rendering Mandelbrot on your FPGA, but you don't have enough memory to implement the frame buffer, to now like, oh shit, I need DDR3 to implement this frame buffer because I want it to be fast enough, and it starts like escalating the project. So I guess in terms of game wise, I like Logic World because it gives me like the speed up over Minecraft like that, but there are some limitations like the screen and whatnot. That's why you have to have modded in screens. But I'm trying to move more towards real life stuff, or like taking the projects that I do and make them more similar to what you could do in real life. So I don't know. I'm not like, I want to finish that quote unquote GPU that me, Nano, Pensy, Omegang, so us, that our group is working on, because like that would be like cutting edge in terms of Minecraft. What you can do in Minecraft, having a full 5 Hz pipelined, like vector stream processor, you know, graphics pipeline unit, whatever you want to call it. Once we get that done, like I think I'm probably gonna call it quits in Minecraft and do everything in Logic World or digital from there. Because like you said, Minecraft, you're so limited in what it can do. There's so many abstractions that have to be made, and I've played Minecraft since what, 2012, 2013. So shit, we're coming up on 10 years. I created my channel in 2012 or 2013. Started uploading about Minecraft around then. It's been a long time. Alright, so let's get back into this. So we have 13 and we need to square it. Shit. Did 13 times 3. 169, yeah, and 10, 9. 9 times 3 is 24. 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 9 times 3 is 14 by 14. What the fuck was that? I forget my simple squares. We have 196. And that's 12, 4, or C4, whatever you call it. $15 by 15 is then 225, which is 1, 0, 0, 0, 1. So let me just double check that. Yeah, 1, 1, 1, 0, 0, 0, 1. Okay, cool. And so now, if I set up some levers here, sometimes it bugs out. So that should be 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, we get 25, 36, 49, 64, 81, 100, 121, 144, 196, or something like that. Yeah, whatever. And then, yeah, 225. Cool. So each one is different, unique, and it's working. So we just generated, we have a few, I kind of want to make this more like, what the fuck? I don't like how that's so tall. I want it to be the same encoding style as that, but I don't know. I'm not going to redo it. We'll keep it as it is. Alright, so we have that, and now we need a 4-bit multiplier. So a 4-bit multiplier has, what is that? Oh, that would require an 8-bit lookup table, so we're going to actually have to build a 4-bit multiplier. Alright, so let's do that. Let's see how compact I can get this. Actually, let's do it like this. I need to figure out the best way to lay out these AND gates. So ideally, if it's 2 by 2, I would like to be able to do it like this. And just put AND gates like this. Does that work? Why does that not let me come over anymore? Shit. There we go. Okay. Do that. Get some pegs. Boom. And that should connect. Cool. All right, so now we have our, A input and B inputs, and we have our products on the outputs, and this is our 1s, our 2s, and our 4s, so we just have to sum up the 2s, right? So what we can do real easily is just grab a full adder that I have here, and I just need, like, what, 3 bits off of it, so yeah, we'll grab it from here. I'll stick that there. Actually, it's got to be rotated like this. What I can do to make it a little bit more compact is actually get rid of this. Make it really easy to get to those input pegs. Shorten this down a bit. Yeah. And yeah, that should do it. Okay, yeah, that'll work. And first, we'll pull it apart, wire it up, and then stick it right on top of it, stuff like that, as close as we can. All right, so if this is, you know, like a single input, so we'll put it right down there. So I'm going to refer to this guy typing in chat as Lines, and and Lines says, "So how's the holiday going for you? We're going in a level 3 lockdown for Christmas. We've had 0 cases for months, but we've had over 60 cases yesterday. Jesus Christ. Well, good luck with that. Stay safe." To be honest, I don't really do much. I live in the middle of nowhere, and I don't have neighbors because I'm in bumfuck New York. So it's not like I don't really know how to say it. Like, I'm not worried. Like, but then again, I don't like do shit. Like, I just stay home, play Minecraft, and go to work. I don't go to bars and crap. That's not my scene. Alright, we got our multiplier hooked up. Why doesn't it make that connection? Which one did it break? That one. Okay. Everything else stay connected? I don't know about that one as well. And it broke. There we go. Damn it. Alright, you know what? Control Z, Control Z, Control Z. And one more. Just rewire it up like this. Instead of trying to go crazy with it. Oh, Cody, okay. He says, my sister and her husband make homemade pasta, so I'm making a pasta board out of wood. His ridge is going along the length of the board to create valleys and oh, damn, cool. Very cool. Alright, let's just test out this multiplier real quick. To double check that it didn't go crazy and built it wrong. So this would be least significant, most significant, least significant, most significant. Alright, so 1 times 2 should be 2. Cool. 2 times 3 is, oh, that turned that off. 2 times 3 should be 6. Yep. 3 times 3 should be 9. And the carry out. Oh, that's right, that's right, that's right. I never fixed this. This is the things that, shit, yeah. Okay, yeah, so there's an issue. This needs to get to there without just going through that. I can't. Oh my god. Oh, and that can't go like that because then that extends. No, that should be fine. God damn it. Okay, so what we can do is turn on no clip. Yeah, but I just bought some gifts. Okay, that still fits. Oh, this is hell. Okay, there we go. Boom. Now it has to connect. Oh, it was already connected there. Okay, beautiful. It has to connect there. There we go. G, E. That's doing that. Perfect. Okay, cool. Now this adder's fixed. I will destroy this. Close that one. Destroy that. Okay, so now we have a working copy we can stack from there. Oh, jeez. Yeah, and so now the carryout needs to go through. Here, and that's the carryout right there, which can be accessed here. Alright, so there's a 9. And now it should take the same amount of delay as, well, everything else. And now we have our multiplier. Okay, so we have 4-bit multiplier, 4-bit square. So now what we gotta do is what we're doing is we're building another square, right? So if you're building a square, there's only one input to a square, and that's the number to be squared. You're not doing a times b, you're just doing a, and it outputs a squared. So because of that, in this you don't see 2 inputs, you see a single input, and you can see it breaks up. The low 4 bits go to the low square, the high 4 bits go to the high 4-bit square, and then the middle bits then fill in the multiplier, and then from there we do a little bit of math to sum it. And it's funny as hell that they say CSA for 2 numbers, carry save adder for 2 numbers, so they mean ripple carry adder there. But we're not going to use ripple carry adders. We're going to do all this using insta carry. If we were building a bigger multiplier, we could use carry save adders and then do the final addition with the with insta carry adders to cut down on relays. But this isn't going to be that big. My goal is to kind of keep this small, hopefully. So we'll see what happens. So first off, I'm gonna grab this and pull it there. So these are our components. And how do I want to do this? First, let's build a board. Let's call it a board. That's a good color. Okay, so what we need is, according to the diagram, we need a low 4-bit square, the multiplier, and then a high 4-bit square. So we're going to grab a copy of this. I don't know how it flipped. Let me grab a new copy. Now the low 4 bits are going to come into this. We will then bring this way. Actually, I'll grab this and pull this all the way to the end here. And then we'll stack the multiplier. Right here. And I want to break out the inputs to make it easy. 1, 2, Let's just double check that I placed those right. I should go to the low one across. Vertical. And then the other vertical. Okay, so now I can start working on this. And pull that in a bit. So hopefully now we can fit the adders that we need right on the end here to do the output the way we need it. So let's generate the input mechanism, and I guess to do that we can probably do this. And we're going to square an 8-bit number. And, I think I can do this to make it connect a little easier. 1, 2, 3, 4. Fuck. Okay. And so now we have A, B, or we'll call that A, B, and then 2 4-bit squares. Now we gotta do this. Wire up the first, well, okay, so, whoops. I will call one of them the low and one of them the high, so it's low square, high. All right, we got our low square, high square, and multiplier. All right, so okay, cool. So the low 4 bits there, A0 through A3. Then the high 4 bits go to the other one. Like that. Now the low 4 bits of this one go into, we'll call that the A input. Oh, I need a 4x4 multiplier. I made a 2x2 multiplier. What the fuck am I doing here? Okay, we can do this. How do I want to do this? I kind of actually, yeah, we're going for a 4-bit while stream here, because I fucked that up. Sorry, guys. So we have 1, 2, 3, 4. I wish I didn't need a full horizontal board like that. Just to do that. The other thing I need to do while I'm here, I'm snacking to make it easy on myself now I'm gonna have a bunch of these. G. Not perfectly lined up, I think it is. No, it's not. Let me just go over one more. There we go. So ones. What? That should make it through that. Oh, chat disappeared. There we go. Alright, Control G. Hold Alt to reposition, slide that over, boom. Wow, that's really dense, Jesus. Nice. Okay. Oh shit. Oh no. Crashed. Alright, go back in. Alright, this is gonna take like a few seconds because the world save is for the server is like 5 megs. Which is pretty big for a Logic World server file. Oh wow, that was much faster than I thought. Holy shit. I mean, it's just my client that needs to connect. It's not like it's restarting the server. Oh, that's why it wouldn't let me get rid of this. Okay. Oh god, this is the hardest part. Oh, I'm not holding shift, that's why. What the fuck? Literally the hardest part. Alright, now that should all be one thing. And now I should just type carry out to carry in. Cool. Okay. This should work now, hopefully. So we're gonna do this bullshit where we pull this out again. And we stick this there. Now you'll notice I don't have 3 input adders, so I can only do 2 adds, or 2 numbers added at a time. That means this has to be split into layers. And the way you split this into layers matters because you can parallelize it, or you can be the lazy son of a bitch and not parallelize it, and then you have a bunch of delay for no reason because you're too lazy to do a smarter algorithm. And we are gonna do the smart algorithm. Grab the carry out right there, boom, okay. And now what we gotta do is, fucking hell, I wish I did this a little smarter. If I used, I can't use through pegs because the issue with through pegs is every 2 blocks they will overlap, and that should probably have been thought out, but it wasn't. Yeah, so you can't do things like this because you can't put one there. Yeah, that sucks. So you'd have to stagger them like this every other one, and then that, yeah. gonna be a pain in the butt. Give me 1 second, chat. All right. Sorry about that. I'm back. Yeah, so what we need to do is we need to put another one of these on top of itself. But these pegs are kind of in the way, which makes that a pain in the ass. Pegs being a pain in the ass. Alright, anyway, so we can try this. And there's so much room that pull that down. Yeah. Actually, undoing, like, really, it really doesn't like being undone. Okay, we're gonna try another thing here. What is hitting? Oh. Now let's try it. Cool. Pull that out. Just something here. Okay, and oh shit. We'll just bring this across like this. Let's see why. Alright, so this now, we're in the 1s, the 2s, the 4s, the 8s, the 16s, right? So 1s, 2, so this is the 4s. So this, it needs to line up here. So what we're going to do is we're just going to drag this over a bit. We want the first input here to line up on the 4s, like that. And now you can see what now you're going to see the overlap here is what gets summed the last time. And then since all this is norm 1, I could then pull this whole board back as close as possible. Anyway, so what you can see that's going to happen here is we're going to have fuck, I really wish I could have made these 1 wide, if it's possible. Huh. I don't know. But yeah, alright, let's not get sidetracked. We're going to do input A. And the next one is input A down here. B, Okay, so now what we can do is grab that and slide it back. And we're good. Look at that. Hell yeah. Okay, so now that is awesome. That is quite compact. Alright, now you can see we need 1, 2, 3, 4, 5. We're going to need an 8-bit adder here, so did that just work? Wow, okay. 1, 2, 3, 4, 5, 6, 7, 8, nice. One, 2, 3, 4, 5, 6, 7, 8. Beautiful. Okay. And now it's as simple as this. I will pull this out. Not easy to get to area. This is the 4s. Whoops. Cool. And now we can see what bullshit we can get away with. That looks good to me. Wow, that's pretty good. That's really small. And that's 3, 6, 7 ticks. Synced. That is really quick. Wow. Look how... I'm actually really impressed with that. Very cool. Okay. Pull that out a bit. Look at that thing. Damn. Are you not impressed with that? Come on. Alright, same deal. Oh, my... I was basically right on with the width there. Okay, so I want to break up the inputs again, so now I want, God, I really don't like how it's 3 pegs per, but actually what I can do is I can be smart about it and just do 1, 2, 3, 4 like this, and then do my 4 inputs like that. So this, where do I want the least significant bit to be? Oh, actually, no, I don't want to do this. We're going to do it like this. Cool. Okay. So this is going to be least significant bit. Then the next vertical is there. Next one. And the last. Now we have the bottom horizontal. And that horizontal. That one. That one. Okay, so now we can do what we need to do. So we have the high and low hooked up. And so the high bits. Oh, it doesn't really matter what we do from here. Okay. Yeah, we just need to split them up into that. So we'll say. That's low bit through high bits, and we'll do low bit through high bits like this. Actually, low. That. Now that should reach. Cool. Okay. So here's going to be the input for the square, the 8-bit number to be squared. Shit. I can't open. Alright, so now we need to take this output and that output and that output and sum them in some sort of way that generates the correct squared result. And I don't even think I tested my 4-bit multiplier, so let's just do like, what, 9 times 9 or something like that, just to check it. So 9 times 9 on this is what? Is that right? It's 5, 1 in hex. The fuck? Carry out. Doesn't make sense. Where's our carry out here? Oh no. Oh wait, no, that's right. Yeah. Oh, because I'm dumb. And then that's not the carry out, that's the carry out. Okay, so that's an easy fix, thank goodness, okay. That's the carry out there. Like, god fucking damn it. Like, that could have been. Yikes. Alright, but I'm only using the carry out in 2 spots there, so now we got the right thing. 5, 1. Good. Good thing we checked that, huh? Okay. And let me, I guess, just fix that here. Don't want to leave fucked up things laying around, just so you get burned. Don't know why that won't connect there, though. Whatever, there we go. Okay, did this one? That one connected. I don't understand. Whatever. Alright, so now we have to sum the outputs up in the correct way. Let's check the diagram here. And we're going to take the bottom 4 bits of the bottom output of the low square. That just gets passed out as the output. So let's just do that. We'll add delay after. We'll sync everything afterwards. We'll just break the bits out that we need. So which one is the low? This is the low. So I will also label this on this side. Low square. I can't even spell. Excuse me. Sorry. Okay, so we want the low 4 bits here. Alright, and once again, for shits and giggles, to make this really, really easy to get to, there's going to be a 16. Alright, I'll just, make that really fucking tall. I know I need the bottom 4 bits. Bottom 4 bits come from the little square. This is the low square. Okay. What the fuck? It said open image new tab. Why is it saving it? I guess that works. Okay. I really don't like the way they're showing this being done here. Not at all. Oh, yikes. Anyway, so yeah, we passed out the bottom 3 bits here. Bottom 4 bits, and now the top 4 bits, which is 3, 4, 5. 3, 4, 5, 6, 7. Top 5. Oh, so we're taking the carry out as well as the bits below that and passing it through. So like that's why there's an extra bit there. Wait, 0 through 3, and then also 3 through 7? That doesn't make a whole lot of sense. There was a... Let me check the 8 byte. I think that's it. Missed. Yeah, they fucked that up. Oh, God. Right, because if you look at this one, it's 7 through 0, and then 15 to 8. So you get an 8 by 8 multiply... Oh, wait, no, that's... Oh, shit, we're looking at the wrong thing there. I want this one here. Okay, yeah, they did fuck it up, right? So you have an 8 by 8 square, so the result of an 8-bit square is a 16-bit value. So you put an 8-bit value, you get a 16-bit value return. So it's saying take the low 8 bits, 7 through 0, and that's the result for the first low. But then to get the rest of this shit generated here, you need to then do something with these, which is 15 through 8. So it's 8. There, it's 8 to 7 here. It's not both 7 and 7 inside here. So on the 4-bit one, you can see that that's a mistake. This is supposed to be 7 to 4. Not 7 to 3. Anyway, ignoring that mistake and catching it, we can move on. So we're gonna have basically this 4. We need to sum the results of this 4-bit multiplication of A and B and sum them. And we also need to then take the square. Okay. Let's pop this up like this. Shit. Wait, why do we have to... Our 8 by 8 multiplier, it's showing 2 outputs. What the fuck? Oh, wait. Wrong. Yeah, that I don't really understand. Why is... Alright, let's do some Googling, gang. This is usually how I find it, because I found a nice article. I just can't find it anymore. Oh, this is it. This is it right here. Oh, beautiful. Okay. This is the multiplier. Multiplier. What? I want to see the other pictures of the circuit. What the fuck? Stop using me to train your fucking neural networks. Again? Boats. And hose. Where is the square? God damn it. had a really, really, really good like link. It was through one of these types. I'm not seeing him with the square though. Oh, what if I yeah, that's the one that I'm using right now. Because I built one of these in Minecraft, right? Like, so I had a good resource to do it then. This is the Vedic multiplier. Multiplier. Those are all just multipliers. I want the square. It's like it implemented recursively, where you build each one off the other. I just don't remember how I did it. This is pissing me off. You know what? How did I do this? I'm looking for a square. There should be 3 blocks inside, not 4. Is this the sheet I already had open? Yeah. It's the confusing one. Like, a multiplier doesn't have 2 8-bit outputs. There's a single 8-bit output. What the fuck? Looking for something like that, but a little clearer. Why are all those have I literally put square. Oh, come on. It's the same sheet. Oh, I see what they're doing, because they're like you have this and then you have it's not square. Why can't it show me all the pictures at once like the other one does? That's so fucking stupid. yeah, what I'm trying to show you is, if you look at them here, it's the same last two stages. Here, there, and so they don't correct for that fuck up in between here. I thought maybe my bookmarks. How do I search? Vedic. That's what I just recently put in there. Shit. No. Oh, this is driving me nuts. Because I did it once, I know it exists. Alright, so let's logic through this then. Oh, that's okay. Okay, stupid. Let's copy the image, open up Paint, and unfuck up their fuck up. Because how does this pass a scholarly journal? Like how does this pass? Tell me, what in the world, what multiplier has two 8-bit outputs when you give it a single, or you give it two 4-bit inputs, right? Like you get a single 8-bit output. You don't get a 16-bit output. Like what the fuck? So let's do that. And like I already addressed, that's wrong here. So that's actually 7, 4. This whole thing's fucked. Make a big font. We'll make it that fucking computer looking font, which is like. Well, whatever. And yeah, so that means 3 through 0 here are just tied low. So we can, or just like, I guess floating, because Minecraft doesn't care, Mandelbrot doesn't care, but we'll just do that anyway. Wait. I'm just gonna go, we'll draw a triangle like to ground. Okay, so there's nothing coming out of the second port there. So that's the only logical thing that can happen. Okay, so we need just a single multiple. What the fuck is it called? Adder. Wow, insta-carry adder. But then what are we doing here? Like, the insta-carry adder is going to sum these two things and produce this result. So what we need to do is delay this by that delay. And delay this by 2 delays coming down here. And delay that by 1 delay. So we have 1, 2, 3. 1, 2, 3. 1, 2, 3 out to there. 1, 2, 3 out that way. So that's everywhere. We'd have to put delay in the system to sync it, I believe, right? I mean, somebody comment in chat if I just fuck that delay up. But that 1, 2, each one now should be 3 delay, no matter each path the output here. So let's count from the output path. 1, 2, 3. 1, 2, 3. 1, 1, 2, 3. 1 right here. 2, 3. 1, 2, 3. Yeah, they're all 3 ticks. So if we put 3, 3, 3, because the IC adders that I have are 3 ticks synced, and then that's 3. So we have 3, 6, 9. Well, okay, wait. So we have 6 ticks in terms of adders here to sync the output, and then the square is 2 ticks, and the multiplier is how fast is the multiplier? Let's look. It's it's 3, 6, 7. So we have to add 5 ticks to this path. We have to add 5 ticks to that path. That's 7, and we have 7 plus 6 total. 7 plus 6. We're at 13 ticks. We're at 13 ticks for squaring a 8-bit value and getting a 16-bit result. That's not bad. But the main reason of doing this isn't for the speed. It's because it requires less logic, less total overall gates. That's the reason for doing this. When you're squaring a number, why build a multiplier that can multiply a range of any 2 numbers, right? It can do any general multiplication where you're always going to tie the 2 inputs together to square. That's a waste of a multiplier. Like you have all this extra logic for multiplying when you're only ever going to square. And because of that, you can reduce the amount of gates, but the delay is still equivalent to that same multiplier. So to be honest, I think this is probably the resource I used when I did this the first time, and I had to rework it myself like this and logic through it the first time. Okay, so what we got to do. First off, I'm going to unwire this here. And luckily, oh fuck, if I want to 1-tick pipeline this, which I do, we're doing Bresenhams, we're doing Mandelbrot, like, let's 1-tick pipeline this fucking son of a bitch. I can't use 6-tick delayers, I have to use 6 1-tick delayers. So, we gotta keep that in mind. So what I think I'm gonna do actually is, do something like this. And I'll just use diodes like this. 3, 4, 5. Shit. G. Jeez, it's painful. That makes sense? No. I want that to be at least significant bit. At least like that. Okay. Okay, so we delayed that by the 6 ticks I needed. So now we need an adder. We need a 8-bit adder. So luckily I can just do this. And now this 8-bit adder has to sum the multiplication result with the high 4 bits of the square result of the low square. So I need the multiplication result. Okay, how are we going to do this? I think. Okay, so we need to sum the output of this multiplication. So this is all 8 bits. So we'll put this into the A input. Okay, so we have the A input done. Now we need the high 4 bits of the low square. So we have the low 4 bits here, and now here's the high 4 bits. So this here needs to go into input, so 0, 1, 2, 3. So this needs to go into 0, 1, 2, 3. Just go into this guy here. Now, is that going to fuck me? No, because that's only connected to that input, and that's even if this is not a diode, they're coming from diodes on the other side. And only one of these will ever be on at a time, encoding the proper result. That should be fine to do. Okay. So now what we need to do is we need to take the low 3 bits off the output of this adder, or low 4 bits off the output of this adder. So basically what we have is bits 0, 1, 2, 3, 4, 5. Oh, that's funny how that reversed. Okay, yeah, so I will actually reverse these, even though it normally wouldn't be in that order. We're going to go like this. Low to high. So now it's 1, 2, 3, 4, 5, 6, 7, 8. And but on the output of these, can that? Yeah, okay. Control G. R, V, V, G. And now the bottom 4 bits here. T, E, there we go. G, T, perfect. Okay. So now we have 6 ticks there, and 3 ticks there, and 3 ticks there makes 6 ticks there. And so now we can actually, I don't know if I want to do this part yet, but I will anyway. 1, 2, 3, 4, 5, 6, 7, 8. Okay, we can do that for now. Might as well pull that out a bit. Oh, and while I'm here. Okay, that maintained every connection. Hey, what up? How's it going, guys? Thanks for dropping by. Am I good? Can you guys hear me? I hope so. So yeah, we got the low 4 bits and the middle 4 bits. Now we need to generate the top 8 bits. So what we do, so we have these 4 bits here, and we need to add these with the full 8-bit result of the square of the high square. So we have a high square. Oh god, okay, so I probably should have reversed the order of the high and low square. But it's too late now, and I'm not going back. How am I going to overcome this here? Is I'm going to do this. Do 1, 2, 3, oops, 4, 4, 5, 6, 7, 8. Okay. And that doesn't really... Oh, fuck, it is higher than it needs to be. Okay. Can you... Wait. Control... G? Oh, that would have been cool. Multi-select grab, like move them all at once. Trying to, like, why go extra in height if you don't need to? So that's looking pretty good. This whole thing looks pretty good so far. It's a pretty clean build. I'm not super pissed off about how ugly it is. Yeah, but so we have our full 8 bits. Now we have to add 8 bits with another 8 bits. So what's nice about this is even though we're getting a 16-bit result, we only ever need 8-bit adders. Yeah, let's do it like this. Yes. Alright, so now what are we summing with this 8-bit adder? Well, we're summing this whole number here, so that's going to be quite the pain in the ass to do. Okay, we got all those inputs hooked up, and now what do I gotta do? Oh, fuck me. Oh yeah, okay, we can do it like this. So I basically then need, if the low 4 are coming through, then I need to do this. Oh, that won't reach. No clip. By the way, is Logic World out yet? I haven't checked in a long while. Last time I think was in closed testing, I think. Your mic is pretty low. You have volume on max and sometimes have a hard time hearing me. Oh yeah, so Logic World is launched. It's $12 on Steam. It's in early access phase. And thanks for letting me know about the mic. I thought I might be having some issues. I was glad somebody spoke up. Oh, I see what happened. Somehow the gain got reset. I had it at 7 decibels and now it's at 0. Okay, hopefully that should be a lot better in terms of audio. Being able to hear me. Yeah, I definitely recommend picking up Logic World for $12. Even though it's like definitely not a polished game, it's fun. Like, and you got multiplayer, and you know you can start doing some stuff. And you know, for $12, you don't feel bad that it's not a fully complete game. Like, it's fine. That's what you get for $12 in early access, but it's not a full AAA title, and you know you're helping out the guy who made it. And I think it's a win-win. Okay, so now what we got to do is just pass this whole 8-bit number out. So 1, 2, 3, 4, 5, 6, 7, 8. Resize this down like this, and we'll grab it from low to high. 1, 2, 3, 4, 5, 6, 7, 8. Low to high. Grab board. We rotate. Get this. Oh yeah, I'm on a multiplayer server right now. Yeah, it's great. Yeah, that's one of the best things about it right now is being able to play on multiplayer. Ooh. Damn, okay. Boom. Alright guys, watch this. So let's pull out a calculator. I have 30 of them open right now. Actually, let's use one of the ones I have open, two open. Alright, so we're going to do, let's clear it. What is, let's just type it in, 1, 2, 3, 4, 1, 2, 3, 4. Obviously that's 250, yeah. So we'll do 255 times 255, it was 65025. Okay, so let's put in a full 8-bit value and see if we get that out. Boom. So put an 8-bit value and see what the fuck we got out. Definitely not the right result. Alright, where'd it go wrong? Well, we have the bottom 4 bits, right? Why is that outputting 1? Alright, let's try a smaller example first. Let's see if it fucks up on something small like 3 squared. Okay, no, that's fine. 9. 7 squared. Yeah, that fucked up. What the hell's going on here? Okay, yeah, so nothing out of there. And it's going to the low square. So we have the low 3 bits going to the low square, yeah. Oh shit, I never fully synced this yet, either. In terms of building logic, which is obviously the focus, I know there's a big difference, but compared to Minecraft, what would you say is the best about Logic World? Really thinking about buying it, but I'm still depending on my parents, so it's not easy. I like it. I like that you can change the server, decorate. I like that there's a multiplayer experience so you can collaborate. Over Minecraft, I think it's better for like learning. Well, maybe no, definitely not for learning circuits. Okay, so here's my issue with people trying to use a game like this to learn circuits. It's like when you're playing a game like this, you're learning the mechanics of the game, and if you already know how circuits work, then you're just learning the mechanics of the game to build the circuit you want to build already. And that's kind of the boat I'm in. That's kind of a boat a lot of people are already in. But if you know nothing about logic, now you're introduced to Logic World. Now you have the problem of the mechanics and understanding the logic, and both of them, and that can be very intimidating, especially because with Minecraft there's like a survival mode. So new people that aren't familiar with redstone logic can play survival mode, encounter redstone naturally, and be like, "What does this do?" Place it on the ground, turn on some lamps with it, and then from there they can get interested, right? But so Logic World, I feel like you already have to have some knowledge of what you're doing. It's not really a learning game. It's more for you to build on. Well, yes, it's a learning game in the sense that you build on your knowledge that you already have, but you need to be comfortable enough to build circuits in the first place. So it depends. Like if you're in Minecraft just playing creative all day because you don't care about the resources, you know what you want to do and you just want to get it done, then Logic World would also apply to you. But if you are playing Minecraft and trying to do doors and survival, then Logic World is not for you. I think that's probably the easiest way to explain it. Okay, so if I do 7 in this example, what happens? Well, then we get 7 times 7 is 49, and we get, did I encode this value wrong? What is 49? I'm gonna laugh if that's what it is, right? 3, 1, 1, 2. No, that's right. Okay. So we have 3, 1. So the bottom 4 bits pass out 0001. So is that the correct result? Yes, they pass out that bottom 4 bits. Oh, you know, maybe the output. Oh, okay. So the issue I'm having right now, stream. Yeah, for $12, I think it's worth it. So the issue I'm having is I've tied these 3 bits or these 4 bits low, and then the output of this went to the high 4. I think that's wrong because then we're doubling this. What this needs to do is this needs to go 3 down to 0. This needs to go 7. Oops. 7 down to 4. So 7 down to 4, get down to 0, and then from there everything should be the same. So let's do that. So the output of the low square here, the high 4 bits, instead of going to the even higher over here, it's nice we can just easily look right up here and go delete, 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 delete. There should be 2 per. And this is going to fix our problem right now. So this here has to go to the low 3 bits instead of the highs. And as long as we can reach, which of fucking course we can't. Okay, for this one, I'm just going to do this. Okay, so we just grab that. Now this should pass out the right result. Yep, okay. Boom. It was ending up to be double shifted. So now, watch this. If we keep going with this, this should work. So 15 squared is 255. Perfect. Okay, so now we're going to go into new territory where we do 31 squared. So let's go to decimal, clear this. 31 times 31 is equal to 3C1 in hex. So we have 1, and this is fucking fuck. Of course it's not right. So let's see what happens. Let's logic through this. So Victor says, feels like Minecraft is annoying sometimes because for big projects you need long wires and everything takes up so much space. Yeah, it does. So it depends on what you're doing in Minecraft. For instance, what Nano and a few others that we're working on was a vector stream graphics processing unit, a graphics pipeline unit, whatever you want to call it. And so because it was non-data dependent, whereas like the pixel 0, 0 didn't rely on the result, or pixel 1, 0 didn't rely on the result of 0, 0. Because of that, like there's no loop, and you could just stream through the data as fast as physically possible. So if you get rid of all torches and you sync everything, you can do a 2-tick pipeline, aka 5 hertz. So you can start pushing the boundaries like that, but then you really, like, the latency, of course, is sacrificed in terms of getting insane bandwidth, but insane bandwidth for Minecraft is still shit. Okay, so why the fuck is this not working? So the low square is getting 255. Or is getting 15, which outputs 255. The high square is getting 1, which outputs 1. So let's follow the high square is getting 1, which outputs 1. So that should just output a 1 on the low 8, a 1 on the top 8 bits. So it comes over here. Okay. So we do have a 1 coming through here. We get a 1 on the low 8 bits, but we also get some other bullshit. But we'll figure that out next. Now through the low path, what does it do? We generate 15 times 15, which is 255, and take the low 4 bits of 255, which should just be 1, or 225, sorry. Should just be 1, and pass it through. So that's correct. So we have that part correct. 0, 0, 1. Now this is off by 1. That should be, this should not be on. Did I do it wrong? I guarantee, maybe I just did the calculation wrong. Let's try it again. Wait, 30. Let's do it in decimal. 1, 2, 3, 4, 5. 31. Okay. Times 1, 2, 3, 4, 5 equals 3c. And then, what the fuck? Yeah, so something is definitely fucked up with what's going on here. Okay, so what are we doing here? This is summing the high bits of the low square with the multiplication result. So we get 1 plus 1 is 0, 0, 0, 1. Oh, is that wrong? Oh, wait, no. 1, then 0, and then 1, 1, and a carry. 1, 0, 1, 1, and a carry. No. So that's summing the right thing. What am I doing with it? Then I'm passing the bottom 4 bits out. And the issue is that this bit should not be on. But it makes sense that it is. Unless A3 or A0. What if I redo this here? Shit, Control Z. Oh, vacant Control Z. Shit. I don't think this is gonna matter, but maybe it does. I don't think it really is going to change anything. Yeah, it didn't. Yeah, because you still get that 1 on. Why is that true? What the heck? So we have 1, 2, 3, 4, 5 times 1, 2, 3, 4, 5. And that's true for some reason. So we have this is going to generate 225. So this generates 1, 1, 1. Okay, I'll do some screen. Sorry. So this is going to generate 1, 1, 0, 1, 2, 3, 1, like that. So then these 4 bits get passed there. And these 4 bits then go in there. So now we have 2, 3, 4 times 0, 0, 1, like that. And so let's check the multiplier. And we should just be getting the input passed through, which we do. And that's exactly what we have on the output here, just 1, 1, 1, 1, which is 15. So we have 0, 0, 0, 0, 1, 1, 1, 1. Okay, so we're taking 15 here, plus 14, and we're getting 30. Which would be 1, 2, 3, 4, 0, 1, 2, 0. Let's do it from this side. Shit. 0, 1, 2, 3, 4, and then 5. Yeah. And so if we're passing, so we should have 0, 0, 0, 1. What the fuck? I'm not even getting that. Oh, is there a left shift in here somewhere? I feel like there's supposed to be a left shift in here. Yes, there is. Fuck. Okay, yep, that's the issue. Look right here. So what we're doing is the square here is doing A high times A high. This square here is doing A low times A low, and this multiplier is doing the multiplication result. We need to left shift it before it goes into here. Left shift. Fucking stupid. All right, so we need a left shift. So this isn't 15, right? So God damn it. I mean, easy fix, but it's so stupid. So we just left shifted. Why did that not work? Guarantee you now it's the right results. So we'll just keep going. Closer. Oh no, it is the right thing. No, well, for some reason that's still on. Let me. Oh, the server doesn't have the hex display mod. God damn it. I can't. If the server had it, I could just pull this 4-bit, do this, and bam. But the server doesn't have the mod. So instead, what I will do is expand this. Yeah. And then can I color these labels? Or is that just changing the text? Shit. One, two, three, four. 1, 2, 3, 4. What the fuck? Okay, so we have fuck that. And now we should have a 3 above it. So we should have, so we're missing a 1 there, and instead it's up there. So what is going on here? What is going wrong to generate that? What is going wrong to generate that? Jesus. So this is right. This is right. What is this summing here? Let's check this result. 0, a 0 and a carry. 1, 1, 0, 1. 1, 1, 0, 1. Yeah. Okay, so the CSA is correct so far. And now I have to sum them, or now I have to. Alright, let's do this. Get rid of everything I wrote. One, two, three, four. Okay, cool. So this becomes 1, 2, 3, 4, 1, 2, 3 plus 0, 0, 0, 0, 1, 1, 1, 0. So let's check and see if that's the correct result. There we go. 0, 0, 0, 1, 1, 1, 1, 0. Okay. So one should be 14 and one should be 30. 30, yeah, 14, 30. So we have, that is not what we have. Oh yeah, it is. We have 14, 1, 1, 1, 0, and then 1, 1, 1, 1, 0. And let's check and see what that sums to. Is 2C in hex, which is 0. Oh, what? Did I not sum? Okay, wait, let's enter it in binary. Clear it. We have 1, 1, 1, 0 plus 1, 2, 3, 4, 0 equals 2C. Oh, I'm reading it backward. Oh yeah, 2C. Okay, yeah, C. Okay, yeah, 2C. God damn, I was reading backwards. Yeah, makes sense. So we get 0, 0, 1, 0, 1, 1, 0, 0 as a result. Okay. So we're getting that. And so we should have 12 on the output there. And we do. Okay, the next thing that we get now is that should be a 2 going into the next adder. Oh, wait, did I do that? Oh, is that what I fucked up on? Oh no. So that should be a 2 going to the, oh. There should be 2 going into the low side here. I see what I did wrong. 2, 3, oops, 3, 4. 2, 3, 4. Hopefully this will connect. Nope. Maybe this will. Yes. This makes more sense too. Of course, this is where the error would come from. I like how I'm good enough to at least be able to work backwards through the map to see where the fuck I messed up. And boom, now we should have the right thing. 3C1. Beautiful. Alright, chat. So I don't know who's still here. It says we got some viewers still. We got 2 concurrent viewers, hell yeah. Oh, at one point we had 5. Oh wow, really pushing her. Yeah, so if you're still here, we have a squaring unit. So we're just testing out with that number, but now it should work with the next number. So let's just calculate it out what it should be. So we have 1, 2, 3, 4, 5, 6. That's 63 times 63 is F81. F81. Beautiful. So now we go to 127 by 127. 3F01. 3F01. And 255 times 250. Oh, whoops. Times 255. 5 is that FE01. Ooh, EE01. Why aren't we getting an F here? F for fail. Fucking. What in the fuck? Oh, that makes sense. Oh, is there something else that needs to be shifted? Shouldn't have to be. 1, 2, 3, 4. That makes sense. Why is... It should be FE01, but we're getting EE01. Man, I was really hoping we were good. I was really pumped for that, but we are instead just fucked. Like why? Like what the fuck? Do I have to right shift that? Like that wouldn't make any sense. Yeah, for fucked, right? That should, all right. Here's what we'll do. Downloads. Yeah, now you get to see all my porn. It's a joke. There is none. Copy image. New. Save. Okay. So this is wrong. Oh God, they literally did everything wrong. How did this pass scientific review? Like, how the fuck did this diagram pass like their review? So there's a L, S, H, F. Alright, left shift. Alright, so what are we doing? We have 1, 2, 3, 4, 1, 2, 3, 4. And so with that, we have 1, 2, 3, 4. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, so that outputs 1, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 0, 1. And then this outputs the same fucking thing. 1, 1, 1, 0, 0, 0, 1. Left shifted. Ah, I see. We're forgetting the carry out of that CSA. Is that it? Yeah, this. No, I can't get. Anyway, let's work through this. So then this is going to be. See, I don't know what to do here with this left shift. If this goes, maybe I need a 9-bit CSA here. That still wouldn't make sense. Because then, well, 8, 7, 6, 5, 4, that's 5 numbers, right? And I only have 4 numbers here being passed in. Would actually having Alright, let's test this theory out. Oh, it would. Oh, it would. Alright, found the issue. Oh man, that feels great. That feels great. Watch this, guys. Boom, we stick that there. Do some bullshit like this. Stick that there. Stick that there. Watch this. Fixed it. Yes, let's go. Let's fucking go. Oh, peace out, Victor. Have a good dinner. I hope you got to see this see that it works before you left. God, that felt good. Yeah, so it like at least they had that notated correctly, where like you do get an extra bit off the end here instead of being 7 down before you get like that 8th bit there, right? Because you perform this left shift and then it becomes 1, 1, 1, 0, 0, 0, 0, 1, 0. All right. So you have to do something with that extra bit, and that becomes that. So you take 1, 2, 3, 4, 5 like this. Pass that like that, and you take these low. Pass it out like that. You take these low. Pass it out like that. Oh, but you also have to add to it this, and that's what. Oh shit! Let's backtrack here. So plus that. So then plus 0, 0, 0, 0. This is 0. 1, 1, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. You add it like that, and then you get 0, 0. Then 1 plus 1 is 0, 2. But carry, so 0, carry, 1. So 0, carry, 0, 0. Carry, 1. I think. And then 0, 1, 1, 1. Yeah, I believe that's what you do. And then now you have 1, 2, 3, 4, 5, 6, 7, 8, 9. You take the low 4 bits here. Boom, that's where your 0 comes from. You take these 5 bits there, send them that way. So now here we have 0, 0, 0, 1. And here we have 0, 0, 0, 0, like that. So now we're sending this way. We're adding up 2 8-bit numbers here. We're adding up 1, 1, 1, 0, 0, 0, 4 zeros, and then 1. Plus, then this number here, which is 1, 0, 1, 1, 1, and the rest zeros. So you get 0, 1, 1, 1, and then 1, 2, 3, 4. And that's your F, E, 0, 1. I should probably draw my arrows where I mean them to go. And that's how we got this. So that is our dedicated 8-bit to 16-bit square. And it was a little hairy. And now what we need to do is we need 2 of these. Excuse me. We need 2 of these, and then instead of a 4-bit multiplier, an 8-bit multiplier. And then that will take a 16-bit input and give us a 32-bit result, so that we can square 16-bit values. Then what I'm going to do is once we can fully generate that 16-bit result, I'm going to then so what this is doing, these are going to be in a fixed point format. It's going to be within a certain range, and that means I'm not going to use the whole output range, and I can start cutting down the bits I don't need, because I want to basically, if I do a 16-bit multiplication, I don't want a 32-bit result, I want a 16-bit result. So I have to somehow cut my output back down to 16 bits, which is easy if you're doing all integers. You just cut the top 16 bits off and leave the bottom 16 bits, and boom, you're good to go. But in fixed point, where I'm going to do something like where it's 16 bits, but it's like 1.7 or 1 plus 7.8, you can kind of cut extra bits that you don't need off the multiplier, because you're not going to reach the full result of like range, basically. So yeah, now basically Control G. There's 2 of them. Oh, fucking hell. I had never seen that before. That was rough. Well, that means it's time to hit the bomb. Oh no. Alright, I'm gonna have to get Commander to load it back up, and it looks like that's the end of the stream for today, guys, because, oh wait, no, it's my game. It's definitely my game and not the, server. Wait, watch this. Maybe it's not the end of the stream. Let's see what happens. Fingers crossed. Fingers crossed and bongs are. Oh, come on. Yeah, so once we get the multiplier, the square done, then of course we need the multiplier. That takes a 16-bit value and 2 16-bit values instead of producing a 32-bit result. Also cuts down to a 16-bit value. But once I got both of those, then we're just going to run through the Mandelbrot algorithm. It'll be really, really simple once we have the multipliers. But it's building the multipliers in the specific format that I want to generate the pixel values super easy. I'm going to actually do the mapping between the complex plane and the XY coordinate plane. This is not loading, like, what the fuck. So like when I do that mapping, like I have like basically a 1-to-1 mapping between screen space and complex plane, and it generates it so quick. Like it just makes like implementing the algorithm so quick, and then it also allows you to do things like change the zoom and the pan, because what you do is you try to center your screen around the origin, and then it just displays that. But then you could change where the origin is, which that's your pan. and then if you change the mappings between the pixels in the complex plane, that's your zoom. So it's really easy to implement. Oh god. Okay, now everything's over here. I thought I just lost all that work. Woohoo! Okay, we're good. It pasted in, it just threw some weird fucking error. Watch it's gonna error, right? No, okay, we're good. Jesus. I really wish there was some way to cut this down, but you know what I can do? I just want to mark it for LSB. Is anybody on the server? I thought I saw Simos. It said Simos is playing, so I don't know if he came on the server. Because it doesn't, like, I don't know how to view anybody online if there was. This is MSP. Okay, I'm actually going to GR. Please don't crash, please don't crash. Okay. And, get rid of that. I want to try to stand these guys up on their ends. So if we do something like this, we lay out another card. Change the color of this to like a rustic orange. That's not bad. Control G. T. I'm just placing it there to see what it looks like. That's actually not bad then, because then I can double that up. Unfortunately, I wish you could place through pegs like really close, like you can regular pegs. Should I fuck with this? I'm going to flip the most significant bit and least significant bit upside. Let's just test something. If I can't even do it. How far out does this come? If we grab this. Oh, we're so close to being able to do that. Oh, what did I just do? Yeah, so that's why I labeled the MSB and the LSB, because I knew that something might happen like that. Okay, so you know what I can probably do now is, instead of grabbing it by there, I can grab it by there. I want that flipped upside down on itself. the fuck am I gonna do this? Oh, figuring out the shifting. That's what I want right there. But now, why isn't that going to work? I see why that's not going to work. What the fuck? Oh, you know how I can do it? I can do this. Just try to get it on that. Oh, it's also because of that. Alright, let's try this. I'm just trying to correct the MSB and LSB. That does it. It's a little bigger than it needs to be. Oh, that's great. That's what I'm talking about right there. Okay, perfect. And now we have least significant bit, most significant bit there. Beautiful. Okay. Okay, that works. That works, and I like it. The only thing I wish I did is get rid of the extra length here. One more time. There we go. Now if I Control G. Very nice. Now this really does lower a whole bunch of components, right? Because what? Oh fuck! I didn't sync this. God damn it! Oh no! Oh, boys and girls, no! I don't know what this person keeps spamming in chat. What that fucking means. Oh. So, issue on this input here. The squares are 2 ticks and these are 7, which means I need to add 5 ticks to the output, to the either the inputs or the outputs of the squaring units. And I can't just add a 5-tick delayer. Alright, like I have to. Oh fucking Christ! I have to actually add 5 ticks of delay like that, so I could pipeline this at 1 tick. Okay, so the squaring units. bigger. Cool. Okay, so now I'm just gonna undo these connections so it leaves those other ones. Also make that really big. Okay, so now we need 1, 2, 3, 4, 5. We need 8 of those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13. So if I move that down, V, and now just do, and now do that until I have 2 less below. Oh no. Okay, do that. No clip. So whenever you disable flying and you land on the ground, it turns no clip back on for you, or clip back on for you, so that you don't fall through the world. Pretty nice, but also somewhat annoying. Alright, so we fixed that one. But fuck, now we gotta do this other one here. And that's painful as hell. Because we already have 5 ticks, and then we have to add another 5 ticks to actually sync the decoder, not just sync it for the other half of it, or 6 ticks here to sync it for the other half of the fucking... Okay, so I don't want to lose my progress on this, so I'll just make a copy and move over to here. GR. And I can then grab it back from this one if I need to and look. Oh, what the fuck? Oh, okay, so we'll copy that. Shit. Oh no. Well, that's why you make a copy, but hopefully this server doesn't do that thing where it like shows you nothing and then you have to like delete or like leave the client and join again. Yep, looks like that's what's gonna. Oh no, we're good. Cool. All right, so delete that. Control G. Send it there. All right, we're gonna make Control G. Send it there. And we're gonna delete this. G R. Grab that. We're gonna try to stick that son of a bitch on this somehow. Like that, beautiful. Actually, I can move that. G. Control Z. Oh, please don't. Alright, something needs to be done with that undo bug. Because that's getting painful. On the bright side, there is at least an undo. Okay. I'll actually copy that instead of just moving it. Oh, I see what happened. Oh no, no, that's so wrong. Why can it go there? Oh. There we go. Okay, that's a little better. What the fuck? There we go. Okay. What's going on here? Definitely has to be just some sort of stacking error. Oh, it was connected on that board when I deleted it. That's right. Yep. Okay. Okay. So now we've delayed them equally. Okay. So we're at the CSA stage, right? Or we're at the output of the squaring stage. And now the output of the square, the bottom 4 bits of the low square. Oh shit. Okay, yeah. Dumb fucking dumbass. Fucking dumbass. How do I do this without deleting things I don't want to delete? That's the hard part in this game. Cool. Okay. So we have this multiplier, and now this is going into the adder. This adder here. So we have the left shift here being done. Now the other thing coming in is the top 4 bits of the low square. So this is the low square. We're going to take the top 4 bits. So it might be easier to do it like this. It's wrong. Could be this guy. What the fuck am I doing? Oh no, I'm doing it right. Okay. Thought I was hooking them up backwards. Okay, so now we have the high 4 bits here coming in as the low 4 bits into this. Yep. And then we sum it. And everything else from there should be the same. Oh, but fuck. I forgot. Oh my god, I'm so fucking stupid. I keep forgetting to sync this. Because now what we have is 7 ticks. Oh, fucking. Alright, let's look back at this. Okay, now the bits go into the output here. Okay, I see. Those last 4 bits here. Right. So we have. I have to do the delay thing again. So we have. 1, 2, 3. 1, 2, 3. Yeah, it has to be something like that. Is that what I had in my previous diagram? I have no idea. All right, let's think through this. So it's 1 tick delay here, or 1 unit of delay, 1 unit 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 delay. So let's look at it from the output path backwards. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Yes, that's the right way to do it. All right. So what I have to do here then is now label the ticks of delay. So this takes 7. This takes. We gotta do that blank. This takes 7. Oops. 7. 7. We got 3. We have to add 3 there because that takes 3. That means we have to add 3 there. Add 3 there and 3 there because this one takes 3 ticks. So because that takes 3 ticks and that takes 3 ticks and that feeds into that one, you have to delay them like that. So for total, we're gonna have 6 plus 7. That's okay. We're still back to 13 ticks. Yep, that's how we did it. So what I need to do now is going into the adder, these 8 bits that are going into, so if this is 7 ticks, I essentially need to add. So if I had 2 plus 5, then I need to add another 3 ticks before they can go to where they need to go. So I really will do this. And then how do I approach this usefully? I guess like this. So I need another 3 ticks. 1, 2, 3. So let's double check this. So we have 7 ticks on this total on this square because it's 1, 2, and then 5 coming through here. The low end of the square oh, I'm doing it to the wrong one. That's what. Oh shit. Okay, thank God that didn't bug the server. I wonder how far back I can undo. I knew it was bound to bug it eventually. Basically, I have to put that back to how it was. And that sucks because God damn it. Alright, what's the orientation I wanted? I want it in that orientation. Can't I get that the way I want it? You know what? Okay. We'll play by your game. We'll play by your rules. T. 1, 2, 3, 4, 5, 6. Hopefully this works. Should that be able to... Oh no, I'm so fucked. I'm so fucked. I'm so fucked. Okay, now what we can do instead of that is... No, we're fine. I'm just stupid. Lazy. Okay. Come on. Where's chat? Oh, there we are. What is this dude spamming? Like, what the fuck? This fucking stupid shit. Nobody gives a fuck about whatever the fuck that means. Alright, so now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 ticks. That makes sense. 7 plus 3 is 10. Okay, I can go into the next. Do I have this right? Okay. So the low square. So the low square, this is what we're doing right here. We have 2 plus 5. Yep. And now we need to add 3 to it on the low 4. Ah, just on the low 4. So we can go God, I hate that book. Shit. What? Didn't crash the server on doing that? Okay. Now we can try to fuck. I hope this still is gonna work by the time I'm done fucking with this thing. Oh, I just fucked up. where you can't undo because I need that. But what actually I need to do is do Control G. Okay, that's what I'm looking to do. What the fuck am I doing? No, I had it right. The low bits need the most delay. What am I doing? I had that right. Oh my god, man. Oh, look, now there's two of them spamming in chat. Lovely. To an audience of like what, 2 people? Okay, so the people spamming it themselves are the audience. Like, great job. Thanks for the views. Let me think about what I gotta do here because I keep fucking this shit up. Oh, we have the low 4 bits. The low 4 bits need to go that way. Okay, so now that I've unfucked that, now I gotta go GR. There we go. Alright, let's see if I fuck this thing up. Oh yeah, I fucked something up. Great. Fuck me. Alright, so the low... Alright, I have it set up here for the example already, so I just noticed it. Alright, I do. I get all of that's correct so far. Then up here, be 0. Okay, so it should be passing, so one number coming into this last adder. Oh, we're still not done syncing it yet, though. Excuse me. We got this path synced. We need to add delay on that path there. So out of the 4 zeros that come out need to be delayed by 3 ticks. Oh, they are. Okay, beautiful. So we have that synced. So we have account for that and that. But what comes over if that's not sent here? No flip. So the 4 bits that aren't sent there are sent 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, and we're sending 5 bits over to that on the low values, so it should have 1, 1, 1, 0. Like What the fuck? Oh yeah, 11101 3101. Yeah. Yep, that's what we got. Three one zero one. Ah, because we didn't connect the other input because it's disconnected from over there. Dumbasses. So the other input of this right here has to make its way in. What's the easiest way to do that? Oh, I think I could do it like this. 1, 2, 3, 4, 5, 6, 7, 8. At least a bit up. A bit up. A bit. Oh fuck. Okay, we can overcome this. Average. Yes, we're good. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Alright, so at least significant bit is gonna be this guy. Oh, that's right. Yep, this is gonna fix it. Then 2 left. 1 left. Cool. Perfect. FE01. Oh, that kind of looks good with that bus going like that. Got a good look to it. Alright, anyway, so we got rid of that. And we can get rid of Alright, let's try this again, game. That's what I want right there. Oh man. Gotta love when that happens. when we load in here, we should have some world back. Oh, now we got somebody who doesn't have a weird Russian names spamming the same shit they were. I wonder if he's just trolling or if he's actually part of the spam crew. Either way, if you're here, can you leave a like? I mean, at least the likes are visible. If you dislike it, nobody knows, but if you like it, other people see, right? God damn, this is... Take a second here, boys and girls. Time's it? Oh, it's only 5 o'clock. Here we go. Or maybe not. Come on. Reset my global coordinates. Okay. But it pasted in. And we have least significant bit to most significant bit. That looks beautiful. It really does. Cool, okay. We just reduced a little bit of height on that side. Perfect. And pull that back a bit. Oh, I can't because I have that output on it like that. Okay. Can I shrink it down? Like, oh, I can shrink it down like this. That frees it up, gives it a little bit better of a look. Oh, I see, because I'm limited at the height of that. Which means actually if I... Oh, I'm really pushing it with where I can get it there, okay. Alright, so what we now have is two 16-bit two 16-bit squares, or no, two 8-bit squares producing 16-bit result. And just like I have a multiplier here at 4x4, now I need a multiplier of 8x8, which kind of sucks. But you can now, can you see like the recursiveness of it? We have square, square, multiplier, square, square, multiplier. And now that whole thing makes up a square, and this, so now we have another square, so now we have another multiplier. Like, it's just a big old recursive machine, but luckily we just need one last multiplier, and then we can do all the additions from there. And then we'll just break up the inputs to that. And then what we can do is figure out our like our fixed point notation, enter it where we want, fill out like all ones where our fixed point will be true, and then cut out the output where we don't need it anymore, and then go back and delete all the logic we don't need. Also, of course, these are unsigned units, so to do signing, you will now then need to apply a 2's complement unit on these as well. The inputs and outputs, but we'll get to that after this. So, I guess we can do that, but what we really got to do is come over here and then build another multiplier. So we have the two, I kind of want to organize these. So we have 2-bit multiplier, 4-bit multiplier, now we need an 8-bit multiplier. And luckily I'm able to keep these kind of small with how I build them. So we need 8 across and then 1 extra. 5, 6, 7, 8, 1 extra. And now, how did I do it here? We did this to the rightmost. Every other one comes to the right like this. Just do this. Now we copy. We position it over. We need to hold control and slide it back a bit. Not quite. There we go. Now we can hook up the diagonals like this. Cool. Alright, now we need to do that, just double it 2 more times. But at least now we can kind of see some sort of pattern. Perfect. That's looking good. Oh shit, that needs to be moved over a bit more. There we go. Okay. Now we have 8x8 output, 256 outputs. Fucking massive. Oh boy. Control G, copy that. This is our adder that's actually fixed, right? That actually works. Yes. Alright, so we'll just copy. Okay, and now I just need to carry out the carry on. Alright, and now I have a big ass adder that I can cut down. Look at this. I believe I only need an 8-bit one at the bottom here. One, 2, 3, 4, 5, 6, 7, 8, 9. I want a 10-bit adder. 5, 6, 7, 8, 9, 10. Oh, fuck, let me do this. 1, 2, 3, 4. Wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. GR. V. And slide that baby back. Cool. I can grab that. See here and start working on it. Alright, this is going to take a little while. Sorry guys. Hey, welcome back. So Victor, we finished the smaller one, and now we are on the bigger one. So here, I'll go back, I'll show you. So here's the small guy. I don't know if you're here when this worked. And we get FE01, which is exactly the right result. So what we got is a recursively built thing. And now I need to double the bit, so I need to go another layer of recursion up. So I have those two stacked here. And now I need to build a 8-bit multiplier to stick with these 8-bit squares. And then using 8-bit multiplier and two 8-bit squares, I can then generate a 16-bit output, squared output. Because right now we have these are 8-bit input squares, and they produce a 16-bit result. So our 16-bit square will produce a 32-bit result. So that's why I have to work on this this multiplier over here next. So that we have quite a few layers of multiplication to be done here. Excuse me. Okay, so how do I do this? So 1, 2, 4. Oh, that's an error. Oh well, if it wired up, it wired up. Whatever, a little bit more compact than it needed to be. Whatever. Alright, so this is 4. So it'll be just about, as long as I just work from there, it should be fine. Now you could probably make these more compact by not shifting to visualize the shift as well. I'm just doing that to help me align everything. Oh, take off, Victor. See you later. If that was 4, then this goes to 8. Okay. Now I just need to do that, but like again, like that. Oh, Jesus Christ. I think that's how we'll do that for now. So 1, 2, 4, 8. So this should be 16. 1, 2, 4, 8, 16. It sucks having to do 2 for both, but like whatever, it minimizes like the pegs used and whatnot, and I don't know if that helps with simulation. I'm just pulling an excuse out of my ass. It allowed me to make the boards a little shorter too. And I really don't like using the through pegs or whatever, like not through pegs, like sockets. So if that was 16, this goes to 32. And perfect, we go one after that one to here. And the reason I have one after that is just to take care of the carry out. Alright, and now we just got fucking one more to hook up. So now we have 1, 2, 4, 8, 16, 64. 1, 2, 4, 8, 16, 32, 64. Oh wait, why am I an idiot? Watch. Right? And let me get rid of this. Wow, that works so much easier. I'm so stupid. Actually, I have to unfuck up that one because I doubled that up by accident. Alright, maybe I shouldn't do that. Oh no, what did I just do? Alright, so this top row all goes down to there. What the fuck is... I really fucked something up here, didn't I? Okay, so that's what needed to be done. Perfect, there we go. So now what needs to happen? We need to then rescale this. Rescale that. Alright, and maybe if we do... That would get it right smack in the middle. How fucking close can I push this? Oh yeah, Jimmy, I had to restart the game like 8 times because I was getting server issues when I did the undo. But yeah, I appreciate the. Give me 1 second, and when I figure out where I'm gonna place this, I'll get rid of it. There we go. Thank you. Oh, thanks, Jimmy. Yeah, I know I can use mounts for a lot of shit, but I don't for some reason. Okay. Yeah, the help menu definitely was helpful for the first few minutes times I was using the game. But now I'm back into the flow of things and it's good. that looks pretty good. Wow. Oh, okay, I saw yellow. Which means if I can get it right there. Oh, why is holding Alt not free locking it? Oh, okay. I'm gonna have to trust it. Yeah, it looks good. Damn, look at that. Damn. Alright, and now we just gotta sum that shit up. Pull that out. I don't know how big of an adder we'll need, but I got this guy just in case. Good thing for instant carry. And I need 2. I believe that's the right stacking procedure. Yeah, I guess we'll find out. Oh, fucking hell. Back. Oh, no. We're gonna be smart. Although I wish it counted and told me how many I had to connect before I was over or under a certain amount. I could do it that way and not fuck it up. Okay. So that needs to be at 4. So 1, 2. Okay. I hope that's 1 to 1. Yep. Q. Yeah, it definitely saves a lot of time doing it like that. What am I doing here? There we go. Okay. Oh, that makes sense. Yeah, if these were space 2, then this one would be space 4, and the next one would be space 8 if I had another layer. Duh. Okay. So that's going to be the beginning. To there. 1 to 1? Yeah, 1 to 1. Cool. And now this is at 4, so 1, 2, 4. Oof. I fucked something up. Oh. I'm an idiot. Why are those highlighted? Hey Jimmy, if you're here. Oh, no, never mind. Okay, maybe it was the server. The server's lagging. Okay, what am I doing? We got bottom. Okay, I see. Now, just gotta do the top, guys. Boom. Okay, and now see that will then go to that bit, so we can go to GR, and that will go to that bit, so we do GR. Resize that. Beautiful. And now we need one more adder stage. And by even sending it through the adder here on these bits, like I could get rid of this and start the adder on the other side. It just syncs it. I would have to then add the layers. Ah, okay. Yeah, I don't know if it was so much as a bug, Jimmy, or maybe the server was lagging, but or maybe a combination of both. Yeah, I don't believe I was wiring these up without using multi-wire select for that fucking one. Alright, so that should be at 16, so we're at 1, 2, 4, 8, yeah, 1, 2, 4, 8, 16. Oh no, I need an extra bit. I just think I need 2 extra bits. Okay, let's try it again. 1, 2, 4, 8, 16. That makes a duplicate, so we go to there. Perfect. That's exactly what I wanted. Perfect. Okay. So now to test this, which God, I should have tested thing parts before I put the whole thing together, but I mean send it, right? 1, 2, 3, 4, 5, 6, 7, 8. One, two, three, 4, 5, 6, 7, 8. Oh wait. One. Oh, that's. Oh yeah, because I fucked up when I did things. Maybe 2 at a time. Okay. Alright, anyway, so 1, 2, 3, 4. There's 1. Let's see. Alright, that looks to be working, at least through the AND gate. I don't care about the result yet. Does that one work? No. Oh, let's just do all of them and see if they, any of them that aren't passing through here. See if I missed any wires. Nope, they're all on. Okay, cool. Okay, that looks right. 1, 2, 3. FE001. Hell yeah! Fuck yeah! Alright. And we can get rid of GR. And it looks like this one will never turn on. Makes sense. FE01. Perfect. Now we can do shit like this. Get rid of all that shit there. Wow, you know what? How often is it that you just like don't test it as you go and it just works? Please don't break any of my connections. Okay. You know, if you ask the simulation nicely, it probably still doesn't give a shit. Cool. There we go. 8x8 mult. So we have 2x2, 4x4, 8x8. Where is the base? Is this the base? Drop the base. Okay. I need more fucking room. Which one of these is the one I'm using? That guy. I could probably rotate this exactly like that. Getting these inputs is gonna be a fucking challenge, but it at least looks good. So this is fully synced here. Let me count the ticks. Is that the one? No, this is the one we're using here. This is it here, right? It's got the yep, got the vertical buzz. Okay, so we have 1, 2, 3. Let's count from the least synced bit because everything's synced to that. 1, 2, 3, 4, 5, 6, 7. Wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10? That doesn't make sense. Should be 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Did I not sync that? Let's check this one. 1, 2, 3, plus another 3 is 6, plus another 3 is 9. Oh, it should be like 11. Oh, fucking hell. 7, 3, 3. So it should be 13 ticks, right? Oh my goodness. This is what sucks about this. So the multiplier here takes 7 ticks. So if this multiplier takes 7 ticks, these have to take 7 ticks as well. So 1, 2, 3, 4, 5, 6, 7. 3, 4, 5, 6, 7. Perfect. Then I add an extra 3. I need to make that 6, that's why. Oh, fuck. I love how I'm still encountering errors. Not value errors, just like timing errors. What? How did it join to the whole? Oh, because I did that. Duh. Alright, so now we have 3, 6, plus 7 is 13. Beautiful. Now this one has 3, 6, 9, 3, 6 plus 7. Yep, 13. Yeah, that's a multiplier, not just a. Okay, that's actually now synced. Okay, so I just need to add 3 more ticks onto those, but is that easy? Am I better off just killing the server? Oh yeah, because I have to make the change to this as well. That's right, that goes there. I can move down an extra one. Oh, come on. And now we're copied. Perfect. Glad that didn't crash the server. Alright, let's do it. I want it rotated the other way. Perfect. Boom. Nice. Okay. So what do we got for the total delay of this thing now? It's 13 ticks, fully synced. 13 ticks to there. Now what about this multiplier? What does this multiplier take? 3, 6, 9, 10 ticks. Wow. Okay. 8, 6, 9. Yeah, so this is 10 ticks now, if I did the math right. 3, 6, 9, yeah. Plus 1 is 10. Which then means if these are 13 ticks and that's 3, I need to extend, or, you know, delay the output on each of these by 3 ticks. And what's the easiest way to do that? I like when it's working out perfect like that. I don't have to fuck with the orientation. Is it gonna reach? Oh shit. Stick that way over there. Cool. And try to reduce this footprint. Okay. So now we have 16-bit squares, or 8-bit square, 8-bit square, 8-bit mult. 16-bit results out of each one. And now they're all stacked, so they're one high. And I guess maybe for consistency I should bring that up to here, but I don't know actually where that's going to need to be, so we'll leave it for now. So now we got to wire up the inputs. So now we're going to have to probably unfuck the fucked up diagrams that they have on mine here. Yep. Okay, so copy image. Let's go to paint. Let's make our canvas massive. Not what I want to do. Control V. Oh, there's coyotes outside. Lovely. So the multiplier was 10 ticks. How did I do this? I did this. Alright, so let's get some timings out. So the multiplier was 10 ticks. Actually, let's not start with that. The square was 13 ticks. The multiplier, what the hell, 13. And this is going to be 10 plus 3. And then this is going to be also 13. And of course, these are 3. So what is that? 19 ticks total? 19 ticks total for a 16-bit square. With a 32-bit result. Not too bad. Not too bad. So I only had to delay the multiplier, which is nice. Instead of previously, I had to delay the squares because they were so much quicker. Okay. So let's make sense of what's going on here again. Get rid of the old one. That's alright. So we have to unfuck it. And what else we gotta fix? Okay, yeah, this is left shifted. You have to remember that this gets left shifted. So this. That's left shift. What the heck? LSHFT. Okay, left shift. And I think that's now the correct diagram. But ladies and gentlemen, it is 6 o'clock for me, and I think, okay, we got another person. I'm not sure if they're spammers or they're just trolling with typing the same shit again. Either way, they're giving views, but I think I'm going to end it here. Next stream, we'll finish the squares, and then we'll start setting up the iterative logic to actually, you know, display the shit. And also I have to get the commander, the guy who runs the server, to add the mods that I need to the server, because for some reason he took off one of the mods instead of adding the new one. So yeah, if you made it this far, thanks for watching. Jimmy, thank you for coming to the stream. I appreciate you typing in chat. For anybody else who isn't aware or is watching this after and doesn't know, Jimmy's the guy who created the game. So yeah, there you go. The Discord for Logic World should be in there's a link for it on the Steam page, I believe, or also there's a Reddit, Logic World Reddit, where you can find out there, and there's a link in my Discord, a link to my Discord in the description if you want to join that. Yeah, so thanks for watching, and yeah, I'll see you guys next stream.